Okay, hello, good morning to all of you. Okay, let's restart the class. Okay, I view first your visual using live YouTube. All right, okay, this is going on. So together with me now is Yun Shan, Zara, Zahira, and Hanan. All right, welcome to the class. Okay, let's start. Let's we sharing. Okay, before that, okay, Aziza is here. Good morning, Aziza. Okay, Muhammad Arif is here. Hi, and then Siti Noor also here. Hi, Siti. And then, okay, good morning, Nurul. Good morning, Nur Nabiha. All right, let's restart. Okay, we have, we ask a question from Zahira. Zahira, you are from where, Zahira? Kuala Lumpur, Johor?
Kelantan.
Kelantan, your voice is very clear. Hi, Kelantan. Hanyan, you're from where, Hanyan?
Kelantan.
Kelantan also, Hanyan. Okay, you also from Kelantan. Hello, means that the line is very clear. All right. Yushan. Okay, you are from where?
Doctor, I'm from Kedah.
Kedah. Hello, Kedah. So means that we can have a good network and then people out there can look, can see, can follow us using live streaming. All right, very good. Okay, now I share without any view. Okay, let's share the screen. All right, let's share the screen. Okay, there are so many. All right, so we go to the better we go to the trapezoidal rule. Okay, let's we go to the trapezoidal rule. Okay, Hanyan, Zahira, we learned already about trapezoidal rule. Okay, we go to the textbook. Where is my textbook? Oh, here. Okay. All right. We go to the chapter. Chapter 5 is a numerical differentiation. Finished already. Now chapter 6 is a numerical integral. All right. It's very easy. All right. Given formula, just use the formula and then try to solve the problem using some example. We give you a very direct example. You can solve using the calculus. But some question is very critical. You cannot solve directly and then very difficult to remember all the formula. So we use the numerical integral, numerical differentiation. All right, Hanyan and Zara, okay, you are be here, but I want to focus my slide. So I want to click here. All right, okay, you are be here. Okay, because some question I need to share with you. All right, numerical. Okay, we go to this. This example. Okay, we want to know what is the example of the trapezoidal rule. We learned already what is the trapezoidal rule with the composite. Okay, with the composite. Okay, we know that trapezoidal rule is a trapezium formula. Okay, the formula is a integral fx. Okay, okay. We want to find the integral between 1 to 4 x divided by sec x plus 1 dx. Okay, you can refer to the textbook, you can refer to the e-notes, you can refer the notes of the PDF file. Okay, you can refer to the notes of the PDF file. All right, so we want to find integral 1 to 4 x sec x plus 1. We know that the basic trapezoidal rule is h divided by 2 fa plus fb. All right, so you can implement a is 1, b is 4, all right, and then h is 4 minus 1 is 3. So you can apply the basic trapezoidal rule. Okay, you can apply the basic trapezoidal rule. All right, so now how to do? Okay, remember again the formula of trapezoidal rule. Okay, we remember now the graph of y equal to sec 1 over x plus 1 is the given. We want to find the area below of the graph 1 over 4. So we create the trapezium. Okay, So the straight line, okay, which is we create the error between the area under the graph, below the graph, and then the trapezoidal rule will create the straight line above the graph. So there is an error, right? Never mind, we can reduce the error using the trapezoidal rule with composite, right? So we want to compare, okay, the first we want to apply straightforward trapezoidal rule, very easy. And then second, we want to compare how the result based on the basic trapezoidal rule and then composite trapezoidal rule. We want to compare. So we know that composite trapezoidal rule, okay, what is a composite trapezoidal rule? Okay, I want to ask somebody here, even though outside no Nabiha is here, Faiza, no Shakila is here, Nasrin, Sabrina. All right, so what is different between the composite trapezoidal rule and trapezoidal rule? We know that the trapezoidal rule is integral between a and b, fx dx equal to h divided by 2fa plus fb. Right. For the composite trapezoidal rule, we decompose or partition or subinterval, subdomain the region to a number of subdomain. All right, so that is set in our mind. So how many subdomain you want to create is depend on you. You can use 10 subdomain, you slice 10 subdomain, you can slice 5 subdomain. So how many you, okay, when you increase the fine grain, the fine slice, increase number of slice, so the graph will be, okay, accurate, and then the error will be reduced because the size of trapezoidal is very small. All right, so now we continue. All right, we continue. All right, okay, so we want to apply fx equal to x divided by zx plus 1. So this is a basic trapezoidal rule. 3h is 4 plus 1 is h. The size of interval 4 minus 1 is 3. 3 divided by 2, fa, a is 1 and b is 4. So you can get the answer. Can you press your calculator? So very simple. Don't forget, f is 1 divided by 1 plus 1 third, or 4 is 4 divided by 4 plus 1 third. All right. So please insert your answer here. 1 divided by 1 third 2 plus, okay, 4 divided by third 5. All right. You can get the answer. I put it as alpha. All right. You can get the answer here. All right. What is the answer? Okay. I just apply straightforward trapezoidal rule. Still remember, yeah, I'm repeat again, the formula is h divided by 2 fa plus fb, because we just we not do a slice, we not do a partition, we not do a decompose, we just use a straight trapezoidal rule, trapezium. All right, so now, okay, come on, we get the answer. The answer is, okay, use the calculator, please use your calculator. It's a 3 point something, am I right? 3 point something. All right. Please use the calculator. I'm waiting from you. Okay. Can somebody here? Hanian, Zara, Yunshan. So when you straight using trapezium or trapezoidal rule or basic trapezoidal rule, you can get the answer 3 point something. Can you find 3 point? Can you answer my question? 3 point. Okay, what is the answer? 3 point something. Can you get the something to xxx to? Can you get? Use your calculator. All right. Can somebody answer at the top chat? All right. 3.74. All right. This is Siti Nordadira. All right. However, we know that the answer is not correct when we compare with the exact solution. All right. When we compare with the exact solution, the result is not accurate. So what should we do? We need to find the alternative way to get the graph close to the exact solution. How to do that? All right, we are using, okay, I think my voice is not clear, very clear. All right, my voice is clear, very good. So to solve this problem, okay, I'm using composite trapezoidal rule. Okay, now I continue with the composite trapezoidal rule with the size of interval 0.25, meaning that the graph is sliced into how many number of interval? Okay, 12 interval. Okay, we slice, okay, we cut the graph, the size of interval between 1 to 4 to the 0.25. 0.25 is a b minus a divided by h is a n. N is a 12. 12 subinterval, 12 subdomain, 12 partition. All right, so the graph is very fine. All right, so b divided by a, b minus a divided by h, 4 minus 1 divided by 0.25 is a 12. All right, so we can apply the trapezoidal composite. So trapezoidal, the strong of the trapezoidal composite is they can apply any types number of sub-interval, any types of the interval. You can use 12, you can use odd number, even number, 11, 10, 9, 8. You can use any number of sub-interval, all right? I'm using 12. Okay, come on. I'm doing the formula of the trapezoidal rule. You still remember the formula is h divided by 2 f naught plus fn plus 2 times f1 plus up to n minus 1. N minus 1 is 11. All right. So we just find the initial f naught, and then the last n, f12. The rest is a plus 2, f1 plus f2 plus f3 up to plus f11. So very easy to remember. Okay. Okay, you need to remember the early f and the last f plus 2 times other f. All right. So easy for you if you can write in the table, because you have so many f, f0, f1, f2, f3, f11, f12. All right. So however, you need to make sure there is a 2 part you put aside. You put aside f0 and f12. For f1, f2, f3, f11, okay, you put another side. Why? Because, okay, you can see here, okay, you put aside, okay, for f0 and f12 because you just do a summation. However, for f1 up to f12, you need to do a summation times 2, all right? Before you do you times with h divided by 2. H is a 0.25. So this is the way I ask you to create the table. All right. So what to do? Okay, you need to use equation. Put the F1, F2, F3, F4, F5, F6, and so on. All right. So now find F. F is a x divided by set x plus 1. Okay. F is what? Is a x divided by set x plus 1. All right. So for F1 and F11, you put aside, yeah, because you need to do a summation all the F and times 2. All right, how to use your calculator to make it more simple and very fast? Okay, you set F first. You set F. F is a xi divided by xi plus 1. Set F. All right. Okay, control the calculation. Maybe you can use 4 decimal places or 3 decimal places. As usual, we're using the 4 decimal places. X is start from, you create X because you know already the X naught is 1. X12 is 4. All right, you just know A and B. All right, so you do the domain of X plus 0.5. 1, 1.0.25, all right, 1.5, all right, and then you continue, all right, you can continue with the X. And then F0, okay, F0 you put aside, F12 you put aside, you separate with the F1, F2, F3, F4 up to F11, all right. Use the formula, okay, 1 divided by set 2, 1.25 divided by 2.25, all right, 1.5 divided by 2.5, so up to F12. F12 is a 4 divided by set 5. All right, so now we already do the multiplication summation for F1, F2, F3 up to F12. All right, so put aside. You can see here how I put aside. You can see here. Come on, we look and see how I arrange a put aside from F0, 1 divided by 2, set 2, F12, 4 divided by set 5. Okay, you plus F0 and F12. And then the others is F1, F2 up to F12, you plus another side. You can use your calculator to get the answer A and B. To get the answer A and B. What is A? Okay, F0 plus F12. What is B? F1 plus F2 plus F3 up to F11. What is H? H is 0.25. Okay, what is X2? X2 is 1 plus 2 times 0.25. So you create X up to 12 subinterval. Okay, you create F from F0 up to F12. You get the two-part summation Fi, I from 1 up to 11, and then F0 plus F12. All right, so you can get the answer here. F0 plus F12 is a 2.4960. Summation F1, F2, F3, F4 up to 11 is a 14.4425. All right. You can use calculator if you want to make the fastest way. All right. If you want to make a fastest way, okay, you just use your calculator. Keep safe. All right. Use a function fx equal to x divided by set x plus 1. All right. So now, okay, Eng Yun Shan, can you use your calculator? Hanian,
Yes,
can you
Doctor.
use? Very good. Can you get a summation Fi, I from 1 to 11?
Yes.
Using calculator, don't do manual one by one. Okay, doing one by one, you cannot do like that because they will spend your time. You can do, but spend your time. All right. Can you do, Hanian?
Yes,
Hanian?
Doctor.
Okay, can you explain, Hanian? You want to share screen with you? Can I share screen with you, or you just want to explain only? Can you explain? All right. What should you do? Explain je lah. Explain. Alright. The first, mode fix 4. Second,
Masukkan yang F2.
aha.
Equation F.
Okay. What function you use? What should you press? How to press? How to press?
Alpha F equal to X over set X plus 1. Then substitute value of X and then get F.
And then masuk data X kan? Masuk data X. Masuk data X for every particular X from X0 up to X12. Alright. Dah masuk data and then you can get F. Am I right?
Yes.
Okay. How to get summation Fi, I from 1 to 11? Straightforward from the calculator.
Summation. Shift. Just.
Cakap je.
Just tambah je.
Tambah macam biasa je. Tambah semua. Okay lah. You can tambah semua. Tapi kalau guna calculator, okay, straightforward you can get summation Fi from the calculator. Very good. Yeah, very good. Alright. Okay, try and the rest please try. Okay, before that I send your attendance. Okay, I send your attendance to your Telegram. Okay, come on, I send. Alright, I forward. Alright, you can send your QR code here. Alright, for your attendance. Okay. Before then, I'm also request you to press your calculator. Alright. Why? Because we hope that you can use your calculator straightforward. Kalau nak tambah saja macam ni, tambah saja, okay. Alright, tapi if you can press your calculator straightforward and then save and then get the summation I up to 11 equal to B, all right, is much more better, all right. Okay, even though the size of interval pun is not too big, it's just 12 summation, you need to do it 12 times, all right. So come on, we continue again. So this is request, okay. And then your answer now, when you plus A is a summation F0 and F12 is 2.4960. And then B is a summation I up to 11 is equal to 14.44235. So times H 0.25 divided by 2. The answer is 3.9229. All right. So this is the, when you compare with the basic trapezoidal rule, the answer is very far. Okay, the error is very far between composite and original basic trapezoidal rule. So meaning that composite is much more better compared to the exact solution lah. We do the comparison with the exact solution. Right? You can find the exact solution. Okay, you can use calculus and so on. Okay, now I'm also asked a question. Okay, what is my question? Come on, I want to ask a question here. Okay, since you know, the question is, come on. Okay, this is my question. All right, the first is, okay, I want to partition the data to a small number of interval where the size of interval is h 0.5. Right. So meaning that I need to apply the composite trapezoidal rule for F0 up to F6. Okay, 0.5. All right. And then 1.0, 1.5. Okay. And then 1.5, 2.0. And then 2.5, 3.0, 3.5, 4.0. So I just create 6 number of intervals. So meaning that the size of composite that we get through the between composite trapezoidal rule with n size interval, in our case is 6, okay, is much more bad compared to the when we use a size of interval 0.25, right? So which is more accurate when we compare with the exact solution? So the answer is, when we do the composite trapezoidal rule using very fine grain, the result is much more accurate compared to the size of interval or number of subinterval is coarse grain. Coarse grain. C-A-U-R-S-E. Coarse grain. So we need the fine grain where H should be a very small. I can use 0.1. So meaning that I have a 0.1. Wow. So there are so many n. N is a 4 divided by 1 is a 3 divided by 0.1 is a 30. 30 size of interval is much better when you use 12 size of interval and then compare to the 5, 6 number of interval. So in the trapezoidal rule, there is not so much rule. Just use a very fine H. Okay, whatever number of n, whether odd or even, the formula is still using F0 plus Fn plus 2 times F1, F2 up to Fn minus 1. All right, very simple. Okay, very simple. Okay, so now I want to ask a question. What is the simplest rule for the trapezoidal composite method? What is the simplest? Okay, what is the rule? Okay, means that what is the element? Okay, to apply trapezoidal rule with composite. Okay, I'm using this one. I said trapezoidal rule with composite. Okay, trapezoidal rule with composite. What is the element? Okay, you need to focus. Okay, the first is what? Use any types of n size of interval using the H. H is a size of interval, any size of interval. So meaning that you can use 0.1, 0.2, 0.25, 0.5, whatever all right, whether you create n is a number of interval odd or even, you can apply the trapezoidal rule. There is no element, okay, there is a very simple. Okay, now we know that trapezoidal rule still create the error because we are using trapezium for every area, all right. So how to reduce the error? So this is my question. All right, how to reduce the error? Since, okay, we are using a very simple, okay, since we're using a simple trapezoidal rule or trapezium, okay, rule, so we can reduce the error between the error below the graph and then error based on the trapezoidal rule. All right, so how we want to reduce, okay, which one you want to reduce? The error lah. You can see the straight line, the trapezium between A and B, and then the small error that you create by slice the area using the composite, okay, using a composite trapezoidal. All right. So in this case, you create still creating an error because there is an error between the trapezium dan the graph, okay, the area below the graph. So you have two error here, all right. So in this case, to reduce this, we are using composite trapezoidal rule, which is create a small error between the trapezium and the area below the graph, and then trapezoidal rule with the basic, where we create a big error because trapezium is a straight line above the graph. So there is no even, there is no odd for n. You can use any types of n, okay, whether even or odd, because, okay, you just focus on the basic trapezoidal rule between A and B, all right. Integral between A and B equal to h divided by 2 times FA times FB. This is a basic. All right. I also have one question here. I try to compare between the composite trapezoidal rule and the basic trapezoidal rule for 0 to 3. F is a 1 divided by x power 3 plus 1. All right. So it's very easy. Our F is 1 divided by x3 plus 1. Use your calculator. So it's depend on the h, how much h you use. Trapezoidal rule formula is very easy. 3 minus 0. Okay, you know that the formula kan? Alright, 3 minus 0, okay, equal divided by 2 times f 0 plus f3. Right, so this is very simple. Okay, but now when you want to start using composite, you need to choose a number of n. N is a b minus a divided by h, is the number of h. In our case, I'm using 0.3. Okay, 0.3 is, if I'm not mistaken here, 0. berapa ni? Okay, I'm using 0. Come on, if I can slash. You can go to your notes. Okay, you can go to your notes. Okay, come on. I share screen. Okay, I think I have a notes here. Okay, share screen. Okay, if I can get the PDF file. There is this one is a PDF file. I share with you the PDF file. Okay, the question here is a H 0.3. You can see here 0.3, right? Okay, this is a question that I want to express here. Okay, H is a 0.3. I close here, all right? So I can get how much, okay, the different error between the trapezoidal rule and then composite trapezoidal rule. And n is a even. N is a even. Even two meanings that I'm using 10 here. I'm using 10 here, all right? So actually, you can see most of our example, n is even, all right? N is a even. Okay, now to reduce this error, okay, we go to the Simpsons rule. Okay, what is a Simpsons rule? Okay, it's depend on not just between A and B, but you need a point between A and B. So meaning that you need 3 points: A, okay, B, and A and B. okay, between A and B, which is A plus B divided by 2. All right. Okay, so this is a new formula where n should be odd. Okay, it should be odd. Okay, let's continue to the next session. Let's I share screen. Okay, if I can share here. Okay, we go to the Simpsons Rule. Okay, the introduction to the Simpsons Rule. All right. Okay, we go to the Simpsons Rule. Okay, and then we focus to the Simpsons Rule. Okay, go to the page. Okay, we go to the textbook. The Simpsons Rule is a page 137. Okay, where is the Simpsons Rule? You can go to the book. Come on. I think all Hanyan, Zara, and then Yun Shun also have the books at the page 137. Or you can go to the, I stop sharing. Okay, I'm stop sharing here. I go to the PDF file. Okay, stop sharing here. You go to chapter 6. Okay, PDF, you can go to the e-learning. Okay, you can get through the e-learning. Okay, you go to the chapter 6. Okay, here. Okay, this is a Simpsons Rule. Okay, Simpsons Rule is using polynomial quadratic P2, meaning that polynomial degree 2. Okay, or we call as a parabolic. Sometimes we call as a quadratic. All right, parabolic because it's in the curve. You can see here in the curve manner. Okay, y equal to p2x. You can see here is a curve. All right, and then the formula using 3 point fa, fb, and fa plus h. H should be b minus a divided by 2. So fa plus here is a plus b divided by b minus a divided by 2. All right, so they should be correct based on the 3 point. Where is the 3 point? You can go here. It's a parabolic. Y is equal to p2x. Tell us with the order 2 is a parabolic, and then between a and b, and then there is a 1 point between a and b, which is a b minus a divided by 2. It's a center between a and b. So the Simpsons will create based on the 3 point. So when we do a composite, we need to create another 3 point. All right. So the 6 should be times 3 lah. All right. 3, 6, 9, okay, 12, 15, 18, 21, 24, 27. So this is the way how we do a sub interval. But I cannot use so many number of sub-interval because it's really peak time for you to complete the question. So I'm using maybe 6 sub-interval, 9 sub-interval, and so on. All right. So should be divided by 3 sub-interval because the basic of quadratic for Simpsons Rule is based on 3 point. Okay. So now, come on, we go to the next session. All right. This is a basic Simpsons. Okay. I share screen again. All right. I share with the my material today is a Simpsons Rule. Okay, it's a Simpsons Rule. Okay, we go to the Simpsons Rule. Okay, now, okay, yes, what is a Simpsons Rule? Okay, many times I said it's based on the polynomial quadratic or parabolic. Okay, meaning that there is a parabolic. Before this, is trapezium. It's a trapezium, straight line. But now we create the parabolic. However, parabolic is also create the error. So look and see how we create the error. Okay. All right. So we can use here. I'm using a trapezoidal rule based on what? Based on the okay. You can see here it's come from the Newton forward different formula. Okay, it's come from the Newton forward different formula. okay, based on the f naught plus, okay, so remember, okay, forward r delta f naught plus r minus 1 delta f naught, okay, delta squared f naught divided by 2 factorial. All right, it's just parabolic. Okay, parabolic means that we just focus on the delta squared, right? So now we know that r is what? Is a number to achieve the x. Is a x minus x not divided by h. We are many times write r. R is a process of x naught to achieve x, okay, with the size of interval h, all right? So Newton forward is uniform data because the size of data is h, all right? So now when we write a integral a and b f naught x naught, okay, we know that the size of interval is up to x2. So my question, why x2? Come on, Hanyan, when I said x2, because we start from the 3 point kan. Tadi just now the basic trapezoidal start from the x0, x1, x2. It's a 3 point. It's a 3 point. Because it start from the, come on here, Newton forward different formula or polynomial quadratic or parabolic. Parabolic is a power 2. All right. So now, okay, let's we continue. Okay, this is a basic. Okay, the terminology. So let's we integral P2 is a Newton forward difference or polynomial quadratic between x0 to x2. x2, you need to remember, I said that we have a 3 point. If you want to apply the trapezoidal rule, there is a quadratic, so power 2. So come on, we do the integral between f naught plus r delta f naught plus r minus 1 divided by 2 factorial delta squared f naught, okay, respect to dx. Okay, so in this case, okay, many times, okay, we do the integral respect to r. R is what? Dx is what? Is r h dr. We remember already. All right, we remember already. Okay, we know that x equal to x minus x naught divided by h. We do the first derivative dr over dx. You will get 1 over h, yeah? Because you want to derive respect to x. So 1 over h, okay, 1 over, okay, dr over dx equal to 1 over h. So dx is a h dr. Okay. So now your integral is based on the respect to dr. Okay. H you put half of the integral. Okay. You need to remember, yeah, many times I'm always remind you dx equal to h dr. Okay. So now, okay, you can get here, okay, you need to find here integral r power 3, okay, because you do the integral r power 3 is what, or r power 2 is what? R power 3 divided by 3. Yeah, kalau r power 3, r power 4 divided by 4. It's a common integral. I'm also right here to remind you the integral of r power n dr. Yeah, okay. So now let's we continue to find the integral between 0 to 2 h dr, okay, because it starts from s0, 0, s1 is 1, s2 is 2, okay, but let's we put h is a 0, is a 1.0, all right. Bring h dr here, bring outside, you can get f0 plus r delta f0 plus r minus 1 divided by 2 factorial f0 dr, okay. H you bring outside, yeah. And then integral f0 is r f0. Integral r delta f0 divided by 2 is r power 2 divided by 2. R squared will be r power 3 divided by 3 minus integral r is r power 2 divided by 2 dr. Okay? Okay, this one is a integral between 0 and 2. Okay, so, okay, any problem here? We have no problem here, right? We want to continue, okay, to do an integral 1 by 1. Okay, put every r you replace by 2. Okay, 2 f0 plus, okay, 2 times f0 minus F1 minus F0, okay, and then plus 1 over 2, okay, R is a 2, R is a, come on, 2, okay, divided by 3, okay, should be R power 3, kan? We need to power 3, and then delta squared F0, okay, we know already the second derivative using chapter 5, okay, is a F2 minus 2F1 plus F0 divided by H squared, alright? So this you need to remember, okay, you need to remember how to differentiate second order derivative F2 minus 2F1 plus F0 divided by H squared. Okay, so now let's continue. Okay, we try to make it the simplest form to get the formula of the basic trapezoidal rule is a F0 plus 4F1 plus F2. Okay, you can create here the formula of basic Simpsons rule is between A and B F0 Fx dx is a h power 3 plus 4 Fa plus 4 Fa plus h plus F3. So this is a come from the Newton forward different formula. Okay, it's come from the polynomial quadratic. Okay, so what you can see here when you compare with the trapezoidal, okay, the graph is a 3 point F0, F1, F2. All right, H is what? B minus A divided by N. Okay, so the size of N now is a 2 for the develop the trapezoidal rule. Okay, now why we need to go to the composite trapezoidal rule? This is common question. Come on, somebody can answer me. Why we need to go to composite? Why need composite? Okay, kita now is a Simpson rule. Okay, Simpson rule. Okay, why we need the composite Simpsons rule? This is my question. Okay, my question is why we need composite Simpsons rule, right? Okay, this is a common question answers. Okay, you can answer. Okay, can I get the answer from somebody here who are joining a class? Hanyan and Zara. Can you answer my question? Who can answer? Why we need composite Simpsons rule? Why? Can somebody answer my question? Why we need composite? Why? Because?
To minimize the error.
Yes, very good. Okay, to minimize the error. All right, thank you, Anyan. Let's be focused to our lecture to the composite Simpsons rule because we want composite is a trapezoidal rule. Okay, it's a trapezoidal rule. So you can see graph here. When you use a trapezoidal rule, this is a parabolic. All right. However, when you the size of interval is not actually this big of the parabolic, we need to decompose because we can get a small parabolic. Okay, when we do the compose, you can prove the simulation of the composite trapezoidal rule by using a 3 point x0, x1, x2. All right, xi plus 1, si plus 2. You need to use 3 points. However, the trapezoidal rule, you use just 2 points, x0 and x1. But here, you need to use 3 points. When you use 3 points, so the n, okay, the set of the composite should be in the odd number, not odd number, 3 times, okay? Okay, F0, F1, F2, F3, F4, F5, up to n. So what is n? Should be times 3. 3, 6, 9, 12, 15, 18, 21, 24, 27. All right, so the formula of a 3, okay, the formula of 3. So this is how we composite the formula. Okay, we use 4 times F1, F3, F5 odd number, and then 2 times 4, 2 for 4 for 6, for 8 is an even number. All right, so this is a formula of the composite trapezoidal rule because every partition using the formula 3, right? So you can create F0 plus Fn plus 4 times odd number plus even times even number. All right, so you can see here I'm creating, okay, I'm create the composite Simpsons rule using one part, another part, but should be a 3 point, should be in a 3 point. All right, so you can see here the n should be even. Okay, the n should be even, and then you can find the h. H is a b divided by a divided by n, so you can fix the value of n. In my case, okay, I'm using how many n? Okay, n should be even. Okay, if we start from the f0 to f2, x2 times to x4, x4 times to x6, x6 to x8, okay, x8 up to x10 should be in the even number, in the even number, all right, because there are 3 points. Okay, trapezoidal rule different kan, x0 up to s1, s1 up to s2, but here you need to use odd number. Okay, you need to use even number. X0 up to S2, S2 up to S4, S4 up to S6, S6 up to S8. Okay, should be in the even number because your partition should be 3, 3, 3, 3, 3. Okay, 3 partition, 3 partition, 3 partition. Because the basic Simpsons is based on the 3 point. Okay, when we do like this, okay, you create a formula. Okay, every partition between x0, x2, f0, dx, you need to create the formula, okay, using the Simpson trapezoidal rule. X2 up to x4, f2, fx, okay, so you also create in the trapezoidal rule up to x8, x10, fx, f8, dx, so you can also using the composite trapezoidal rule again. So means that, okay, you need to use 3 point, okay, 3 point. So the formula of the composite is h divided by 3. Still remember kan? F0 plus 4f1 plus f2. One set of the interval using the 3 point. F0 plus 4 f1 plus f2. One set. Another set is a h divided by 3 f2 plus f4 times f3 plus s4. Alright, so another set for the sub-interval using the trapezoidal rule. Alright, so now if I hope you can remember the formula. If I want to continue, it should be what? If I want to continue this, it should be what? If Hanyan, Zara or Eung Yun should be what? Between the x2, x4 and x6. What is a composite, basic composite for the portion, okay, the partition of the interval? Should be what? H divided by 3 lagi, f4 plus 4f3 plus f6. So it should be apply the same type of the Simpsons rule. What is that? Based on the 3 points. So I cannot use for any even number. No, I need to plan using the n, the specific n. All right. So s4 plus 4, s5 plus f6, and then next, okay, is a f6 plus 4, f7 plus f8 plus h divided by 3, f8 plus 4, f9 plus f10. All right, plus, okay, and then we can continue up to fn minus 2 and fn minus 1. So what you can create here, that I told you there is a 3 terms for every particular portion or particular partition. So you can see here f0, okay, and then 4f1 plus 4f3 plus 4f5, all right, plus 4f7 plus 4f9. So all is a odd number. Okay, the odd number should be times by 4. And then the even number, you can go to even number, even genap, yeah. F2 plus F4 plus F6. So this is an even number. The odd number you need times 4, but the even number you need to times 1. So I go to even number, F2 plus F2 plus F4 plus S4. You can see F6 plus F6, F8 plus F8, F10 plus F10. All right. So you can see here, okay, all the even number should be times 2. However, okay, F0 plus Fn should be one particular element that you need to put aside, F0 plus Fn, plus, okay, there is odd and even. If even, okay, if odd, okay, odd ganjil, so you can times 4, F1 plus F3 plus F5 plus F7 plus F, maybe N plus 1. It depends on N. And then plus, okay, you have a even number yang genap. Okay, yang genap you need to times 2 F2 plus S4, okay, plus F6 plus F8. All right, so this is an all even number. Even number you don't need to times 4 because you just times between the before interval for the previous, okay, size, and then plus, okay, odd value for the next size of interval. All right, so you times 2. Okay, so what is the weaknesses of the Simpsons? You need to create based on the 3 points. Okay, based on the 3 points. All right, so this is a final, okay, of the simplest of the Simpsons rule is a h divided by 3, f0 plus fn plus 4, summation fi to equal to 1 up to n minus 1. I is what? An odd number times 2 summation fi I to n minus 2 fi, I is even number. All right. So if fn is even number, you create another, okay, element that you need to find is a, b, and c. What is a? F0 plus fn. What is a b? Summation the odd number. What is d? C is a summation of the even number. So don't worry, okay, don't worry. Let's be focused here, okay. Don't worry because we just now using the same terminology like trapezoidal. However, some Simpsons based on the 3 point because it's come from the Newton forward, or we call as a quadratic polynomial, okay, or polynomial parabolic. All right. So be careful what is even, what is odd. So I cannot give a proven simply by choose any n. No, because I need to create the even. Okay, the even. All right, the even, the odd and even value. All right. So now, can I get some question answer here? Why, okay, we need, okay, three formula. Okay, so studying, my question is the base of Simpsons rule. You need to know the base of Simpson rule is what? What is the basic? Okay, the base of Simpsons rule. What is that? Is a based on what? What is a Simpsons rule? Okay, the basic of the Simpsons rule is what? Is based on 3 points. So you create the formula based on the 3 points. All right? Okay. Okay. I know. Okay, you have a long holiday during the Christmas holiday. So I'm stopped here. However, I give you a simple question. All right. You can go to your Telegram. Okay, you can go to your Telegram. Don't forget to scan your attendance. Okay, I want to share with you, okay, one question. I hope you can. I forward you the question. Okay, takes time. Okay, takes time. Okay, answer the question because I want you to expert in the 2 chapters. What is the 2 chapters? It's between the numerical differentiation and numerical integration, right? So try to answer this is considered as your clarify your attendance today. All right. Okay. Any question? Okay. I'm asking you any question. Okay. What is the question you want to answer? Okay. Integral. We learn two methods today. Is a Newton Simpson's method and Simpson with composite. We learn about the Simpsons composite because we want to reduce the error, the graph below the graph, and then the parabolic created by Simpson's method or trapezium created by the trapezoidal rule. Right? So why we need to control the proven based on the n size. So the n size, if you want to compare, if you want to prove using Simpsons rule, the n should be what? Should be 3 power 3, 3, 6, 9, 11, 12. Right? You can't prove the Simpsons rule when n is equal to 2 or equal to 4 or equal to 5 because you cannot divide it into the 3 point, right? So Simpsons should be specific, Okay, any question? You can write, you can ask the question, even though we have a friend here. Okay, Hainan, Zara, and Eun. Okay, any question from all of you? Any question? No question. Huh? Eun San, you have any question? Hanian, any question? Zara, no question. All right, so till now you can prove composite trapezoidal rule and composite Simpsons rule based on the specific number of n for Simpsons rule. All right, okay. Goodbye. So please go to your continue at the Google form. I'm waiting you at the Google form. All right. Bye-bye, bye-bye, Hanyan and Zara. We continue for the next session. Thank you very much. And then the rest who are watching, bye-bye, yeah? And then the rest who are watching this video, thank you very much. And then please do a revision because we are applying what? Student determined learning and address many video, many e-digital material at the e-learning. Go to the e-learning. Thank you, Ain. All right. Bye-bye. See you next.